So for this part of the unit, I'm going to talk a bit more about one of the more advanced techniques, which is all about transformation and aggregation. So far we've looked at how to read information from the data frame, to store information in individual values in rows and columns, but now we need to look at how to transform it, to use the result of some sort of calculation on the data. So the first thing we're going to talk about is how to go and sort the data. So this is the very simplest transformation you go and do, is just to go and sort it. So we might sort a data frame by values, or we might want to sort by the index, by the row labels. So either a possibility. So either we want to look in a column of cells, or we want to look at a set of the index values. And Pandas gives us two different sort functions depending exactly how we want to go and sort the data. So if we want to do sorting by the index, then that is .sort_index, and again by default that will just go and do a alphabetical or a numerical sort on the index, and give us a new data frame with the value, the rows all sorted. So in this case here you can see that obviously Batman comes first in the alphabet, followed by Black Widow, and then Captain America, and so on. In contrast, sort values will go and sort by the particular column we specify. And for both of those sort methods, we can also tell it we want to either sort ascending or sort descending. So here I'm going to sort by the total column, and I'm sorting with ascending full. So in other words, I'm going to sort from the highest total going down. And so from this we can see therefore that Iron Man has the biggest total score, followed by Thanos, followed by Groot. I'm not going to take any responsibility for those scores or the conclusions one comes to. If you need to sort by a combination of columns, then you can pass a custom function as a key that you want to use as your sorting parameter. So in this case here, I'm sorting by a lambda function, which is going to do a calculation, which is unfortunately scrolled off the end of the screen here, but in the PDF notes it'll all be present, and that therefore does a sort by a slightly different, by a custom calculation using just a series of the columns I'm interested in. Another thing you can go and do with Pandas options, Pandas objects, is you can just feed them into NumPy arrays. And this is because NumPy actually defines how something that's passed into one of its functions should behave for NumPy to treat it like an array. And Pandas, because it's built on top of NumPy, or was historically built on top of NumPy, supports that protocol for how it should interact. And that means you can simply just pass Pandas data frames and series as if they were NumPy arrays. It just works. So for example here, I'm going to pass np.round, and I can just pass it df and then the total column. And the kind of fun thing about this is that NumPy will go and do its business, it'll do the rounding, but then when we get it back again, it still remembers that it was a Pandas series, and so it gives us the correct the correct row labels as well. So that's an example where the kind of Pandas and NumPy are working really nicely together, and you still get back the right thing. That's okay so long as it's kind of a simple transformation. So if it's a value in going to a value out. If you're doing a more complicated calculation and changing the shape of the array, then you might have you might lose that information. Another way you can go and transform a data frame is you could apply a particular function over every row, or possibly over every column in your data frame. And so Pandas has a method .apply, which basically says, give me a function and I'll go and run that function on every row or every column and give you the result of that. So in this example, we've created a function called brains not brawn, which goes and does a calculation for an overall score, which favours some of the some of the columns over the other columns. And so you can see this function takes in a row, and it's assuming that row is going to be a Pandas series, because I'm referring to row.combat, row.strength, row.power, and so on. And it calculates a new result. And then I've taken a copy of my data frame to work with, and I'm going to create a new column, df overall, and I'm going to set that equal to the results of applying brains not brawn, and then the axis equals 1 means I'm applying it that is going down the rows, not across the columns. And so then that gives me an overall value, and I can just sort those values to get an overall score, like so. So this is another way of coming out with a total score, but one that does a slightly different calculation by applying this function. So I can generate new data with some complicated function that I can specify that uses the data from the data frame, and Pandas will take care of running that function over every single value. I don't need to write an explicit loop, and therefore it's much faster doing it that way. Another important thing to go and do is operations called aggregation and grouping. So when we did the describe method in the data frame, we were running some statistical functions, and that again is an important calculation like sum or mean, or more complicated stats to do on the columns. So if we first of all just go and select the data columns that have a numerical data type, because obviously we can't ask it for the mean value of good and evil. That doesn't work. We can ask it for the mean value of columns with numbers, but having figured out those columns which have numbers, we can now say calculate the mean for each of those columns. And it goes and does that and produces a series where it gives us the names of each columns and then their mean value. It might, however, be more useful, rather than just calculating the mean values over all of the heroes and all the villains, to ask the question, well, what's the mean value of each column for the heroes versus what's the mean value of those columns for just the villains? And again, we can do that, and to do that we can use the .group by to first of all collect together the characters by their alignment, good and evil, and then to run the aggregation, the mean value calculation. So this is what we've done. So we do df.groupby and group by the alignment column. So that first of all gathers together all of the good and all of the evil characters, and then to that we call it with a dot mean, so we calculate the mean value for those columns, and that now lets us compare the mean value for each of those columns for all the evil characters and all of the good characters together. And rather reassuringly, we find that the good characters have a mean total and a mean overall score that is higher than the evil characters, so good does win out over evil. Functions like max, mean and sum, which reduce a series of numbers to a single number, are generally called aggregation, and are common operations you need to do in data science. Pandas implements a kind of special method, .ag, which allows you to calculate a number of aggregations against multiple columns all in one go. So for example, I can do df.ag and then parse it for a dictionary where I say which column I want and what aggregation functions, mean, max and so on, do I want to run. And I say I want the speed column and I just want to give the median value to that. And then you can see what it produces as a result is a little 2x2 table where it's calculated the mean value for combat but not speed, the maximum value for combat not speed, and the median value for speed and not combat. So we have some missing data in there because we didn't do the calculation, but it's done multiple columns and multiple aggregations all in one function call. And so obviously that, if rather than being on the whole data frame, that's on a particular subset of the data frame that you've collected together already, that can be quite an efficient way of reducing a large amount of rows and columns into the desired numbers that you actually want. Combination of using group by followed by aggregation creates something which in data analysis is called a pivot table. So called because in a sense you're pivoting the way you look at your data. You're transforming it so you look at it rather than looking at it as columns of data or rows of data. You're looking at a subset of that data along a different axis. And again, in Pandas, we can actually create a pivot table all in one go. So in this case here, we are creating in one fell swoop something which takes the combat and intelligence columns and it aggregates them by their alignment, and then it so groups them by their alignment, and then calculates an aggregation function, which in this case will be mean. Again, it's drifted off the end of the slide, but it'll be in the notes.